Hello everyone. This is the first question of our project and also the first question of the sheet according to the given values. So let us construct the circuit. We need a voltage source. It's over here by pressing the key F2. Okay. By pressing escape it goes. We need a resistor. We need to rotate it and hence central plus R1, then similarly R2 and similarly R3. Escape. We need a voltage control voltage source. In this component system, which has various components over here, E and E2, the polarities are only reverse. We need this one and hence we'll connect it over here, escape, and basically now connect everything with wires. Connected, connected, this two connected, this two connected. Basically keeping R1 and R2 separate is that a voltage dependent voltage source is dependent on the voltage between R1 and R2, and hence by connecting a wire over here and a wire over here. Okay, so now let's ground it. Yeah, so we need to find VThevenin and RThevenin across these two terminals. So let's label this to be V1 or V1. No, since V1 is there, we'll label this VA. Okay, and hence by finding a voltage VA, we can find the VThevenin, which will be VA across these two terminals. So putting values, this is 35 volts. Okay, this is 16 kilo ohms. This is 24 kilo ohms. Over here the gain is of -2 as given. This resistance is of 10 kilo ohms. Okay, now let's simulate the circuit and see what the results are. DC open point, and yes, over here we can see that the voltage VA is -23.33, which gives us the VThevenin. Now finding the RThevenin, we need to short circuit this independent voltage source, and hence let's cut it, connect it with wires, and hence it is short circuited now. But this voltage dependent voltage source can't be short circuited for finding RThevenin. Hence we need to connect a small current source. Over here it is, oops, escape, F2, current source, across the two terminals. on which we have to find RThevenin. Let's connect these two terminals. Let's give a value, for example 1 ampere independent current source. We'll label this to be VB. Okay, and hence by running the simulation we get these values. VB is said to be minus 10,000 voltage. So voltage across this ammeter is minus 10,000 volt and current is minus 1 ampere, and hence the RThevenin comes to be 10 kilo ohms. So now we have got the VThevenin, which is minus 23.33 volts, and RThevenin to be 10 kilo ohms. So now let's construct an equivalent circuit diagram. So a voltage source, okay, escape, a resistor, oops, let's undo it, we need to rotate the resistor, central R, and then connect it by wires. A small extension, and then let's ground this. Okay, so by setting the values, this is the Thevenin equivalent circuit. Okay, so this is the Thevenin equivalent circuit. Let us check this by adding a load resistance. Just connected by wires. Let us give it some value, for example say 7 kilo ohm. Let us label this point to be let us say VK or VL, since it's a load voltage. And now let's simulate the circuit in DC open point analysis. Okay, so yeah, VL is nothing but 9.60711 volts, and current through R2 is 1.3 milliamperes. Yeah, so it's 1.3 milliamperes. So this is the information about the Thevenin equivalent, and hence now try in the original circuit. Let's close this. The original circuit is saved over here, and now let's connect a resistance of 7 kilo ohm and check whether the values are correct or not. So 7k, let's connect it with wires. Here it goes. And now let's run the simulation in DC operation point. And yes, it's again 9.6, and the current through R4 is 1.3 milliamperes.